Hey guys, now we're going to have a look at 9F, which is traversable graphs or traversable networks. So a is traversable if it has a trail that includes every edge. Now, if you remember what trail is from last lesson, that's great. But if not, there's a little bit of a reminder here. So a trail is when you've got some sort of route through the graph where vertices can be reused, but edges cannot. Okay, so we can't use those edges again. Right, now let's reread this. A graph is traversable if it has a trail that includes every edge. So what we need to do here, and I'm going to try and do it with these two, is see if we can go through and use every edge in this graph. Okay, so let me see. I might want to maybe start here. I can start at B. And if I go down here, then go here, then go here, and go here, and go here. Did you see how I just made a trail using every single edge? So that would mean that this graph is traversable. Now I want to see if I can do it with this one, and you can find out whether they're traversable or not through trial and error. So I just tested by trying on that one. So I'm going to do the same sort of thing here. But remember, some graphs won't be traversable. So I might just randomly start in the middle here. So I'll start at E. I can go down here, then over here, and maybe back up here. If I go over to B, then I have a bit of a choice to make, don't I? So if I go down here, that means I'm going to have to then reuse an edge. So if I go over here, that's all good, that works. But do you see how I have to reuse that edge again? So it looks like this one might not be traversable. But it could be hard to work out whether or not they are, because it might involve a little bit of trial and error, and that could be frustrating and take ages. So I'm going to show you a rule to work out whether it's going to be traversable or not. But first, let me just label these. So this one was traversable. And this one we think is not traversable. But maybe I just made a mistake and didn't do it. So this is why we need to know about this special rule here. So all vertices, it will be traversable if all vertices are of even degree, or exactly two vertices are of odd degree and the rest of them are even degree. So hopefully we'll remember what degree means, which is how many edges connect at each vertex. So this is the same as the one before that we did. Same as that one there. Now I couldn't get it to work, but let's see using these rules if it actually does work. So this vertex here that has a degree of 3, I'm going to label them to make it easier for me. This one here has a degree of 3. This one here also has 3. This one here is 3. And then this one in the middle is 4. Now let's see if it fits with these rules. So it'll be traversable if all vertices are of even degree. No, that doesn't work because we've got some odds here. Exactly two vertices are of odd degree and the rest are of even degree. Okay, so we've got 1, 2, 3, 4 that are odd degree, so that doesn't work either. So this one would be not traversable. Which makes sense with my trial before that I couldn't get to work, because there's no possible way to do it. Alright, now let's use these rules here for this one as well. So let's have a look at the degree of each of these vertices. So this one has 3, this one has 2, this one has 4, this one has 2, and this one has 1. Alright, now it's going to be traversable if all vertices are of even degree. They're not, we've got a couple of odds. Or exactly two vertices are of odd degree and the rest are of even. Okay, so there's an odd, that's 2, and the rest are even. So this should be traversable. All right, now let's see if we can get it to work. So let me just, I'll decide to start here. If I go up here, then here, then there, then there. Now I'm allowed to reuse vertices, so then I can go over here and over here. So it ended up working, didn't it? So this one is traversable, and I've shown an example of a way to do that, but the rule told us that it would be traversable. So that's the sort of thing that you're going to have a look at in the questions for today.